Here are the notes for day 4. What we're doing is a bunch of little formulas for these problems. The first is the distance formula, which you can see on the left. Anytime you have a distance formula question, I would suggest writing down the formulas. That way you'll get it memorized. And then underneath that, you see the midpoint formula. Midpoint's a little bit easier because you're just finding the average of the x values and the average of the y values. So the example on the right, I've covered up the answers. So it's going to be your job to take the formulas on the left, take the points that have been plotted here, and use those points and those formulas to calculate the midpoint and the distance. Pause the video, figure out the answer, and then check your work when I move the animals out of the way to reveal the answer. Okay, so hopefully you finished. The midpoint, plug into the formula again, is just taking the average of the x's. So the two x values are -2 and 4, and then the average of the y's. The y values are 5 and -3. Add the x's together, divide by 2, add the y's together, divide by 2. You get 2 over 2 and 2 over 2, which reduces to 1 over 1. It's just a coincidence that both coordinates are the exact same, but according to that formula, we think that the midpoint is at 1, 1, which is right there, and that certainly does look like that might be the midpoint between those two blue points. So now moving the yak out of the way to get the next answer. Distance formula, again, I would suggest always writing out the distance formula so that you get it memorized. First step is to take the difference between the x's, so 4 minus the -2. Second step is to take the difference between the y's, so -3 minus 5. If you do your signed addition correctly, you'll get 6 squared and a -8 squared. Getting the elephant out of the way, maybe. Produces 36 plus 64, the square root of 100 is 10, so the distance between those 2 points is 10. That makes sense because if I take and draw a straight line between these 2 points but make it into a triangle and count boxes, what we have is a triangle that is 6 boxes across, 8 boxes up, so that would lead us to a hypotenuse of 10 using 6, 8, 10 triangles or 3, 4, 5 triangles. I don't know if you learned those shortcuts in geometry, but the distance formula here always works. So if you use the distance formula, you won't have to remember your geometry shortcuts. For the next example, which involves circles, I'm just going to walk you through the material that's written down here. Standard form of a circle looks like this, and the 3 numbers you got to be on the lookout for are the H, the K, and the R. H and K represent the coordinates of the center. So H and K are both positive numbers, and the formula contains a negative. So you got to be careful with your signs in this. The radius, whatever length this is between the center and a point on the circle, squared, shows up in the formula on the right side. So if I have a center of -2, 3, and I know that it goes to the point 2, 0, if I make a real rough sketch, here's the center. The circle is going to go through this point, so I didn't draw the whole circle. But if I can find this distance, then I know that this distance represents the radius. So using the formula from the previous screen, distance formula, substitute in your x's. x2 is 2 minus a -2, and 0 minus 3 produces 4. 4 squared is 16. This is -3, -3 squared is 9. 16 plus 9 is 25. The square root of 25 is 5. So I know that the radius is 5. Now that I have the center and the radius, I can plug them into the formula. X minus h, and h was -2. Y minus k, k is 3, so since the formula is y minus, the 3 goes here and it looks like y minus 3. And then the right side, the radius squared is 25. Doing a little bit of cleanup, minus and negative is plus. This stays y minus 3, and then the radius squared is 25. This is the equation for a circle centered at -2, 3 that goes to the point 2, 0. This example involves completing the square, and I think we're going to postpone it because we'll see completing the square again in a later lesson. Okay, third topic is slope. You've seen the slope formula before. You know that it's change in y over change in x, which means y2 minus y1, x2 minus x1. Example says calculate the slope, verify by plotting points. So I plotted the points, and now I need to calculate the slope. We don't like to plot all the time because it's awfully slow, so we'd like to be able to find the slope just from a formula. So again, pause the video, plug in the values where they belong into this formula, and see if you can get the slope correct. Do the same thing for this example. I've plotted the points, I've given you the formula. Your job is to practice substitution and simplifying. Pause the video and get the 2 answers. Okay, so for the first one, y2 minus y1 is 6 minus 9. and x2 minus x1 is 8 minus 5. Top simplifies to -3, bottom simplifies to 3. We get -1/1, which means that our slope is down 1, right 1, down 1, right 1, down 1, right 1. That simplifies as a fraction down to just plain old regular -1. A lot of times with slopes, it is easier to leave your answer as a fraction. That way you know how far you're going in the y direction, change in y, and in the x direction, change in x. Second example is a little bit different because something cancels out. What happens is when I do y2 minus y1 and x2 minus x1, we get 1 minus 9 for the y's and 6 minus 6 for the x's, which is 0. Since we're not allowed to divide by 0, that tells us that there is no slope. What does a line with no slope look like? It looks like a vertical line. If you think of a vertical line as this, where you try to put an egg on a wall, the egg falls and becomes an undefined mess, which is why a vertical line has no slope. Horizontal lines have a 0 slope because if you were to take an egg and put it on a table, the egg would stay on the table, and so this slope of a horizontal line is 0. People often get horizontal and vertical lines confused with respect to their slopes, so just remember horizontal line, egg stays on the table, vertical line, egg falls off the wall and becomes an undefined mess. The final topic is function notation, which starts up pretty straightforward. There's a couple interesting things towards the end, but what's happening is if I give you a function of x squared minus 3, and if you're going to be plugging in numbers like 0, 2, or -4, wherever there was an x, you're going to put parentheses, and you're going to substitute in a value. So the first one is 0 substituted in squared minus 3, 0 squared is 0, and our answer is -3, which is like saying f of 0 equals -3, or you could say I have the ordered point 0, -3. So I'm going to need you to do the same for the next 2 or 3. Pause the video before I write up the answers, and then you'll see, you'll be able to check your answers against mine. So I've done the first 4, and most of them are pretty straightforward. Again, if you plug in 2, 2 squared is 4, 4 minus 3 is 1. So you could say that f of 2 equals 1, because when I plug 2 into the function, I get an output of 1. Or you could look at it as an ordered pair. If my input is 2, my output is 1. When you're plugging in or substituting negatives, please make sure you have the parentheses. That's important. -4 quantity squared is a positive 16. If you don't remember the parentheses, then you'll have the opposite of 4, which would give you a -16, and that's not correct. So -4 squared is 16. 16 minus 3 is 13. F of -4 is 13, or an input of -4 produces an output of 13. You don't necessarily have to have just numbers. You could have variable expressions. 2a squared becomes 4a squared minus 3. You can't do any simplifying. So function notation, f of 2a is 4a squared minus 3, or input of 2a produces 4a squared minus 3. So for the final two, we got to do a little bit slower. We've got to double check some algebra type stuff. If I take x plus h and plug it into the function, I have x plus h squared. Now you got to be careful, x plus h squared needs to be written out the long way. And so now we need to do all 4 multiplications. X squared plus xh are the first 2, and then xh plus h squared are the second 2, minus 3, and we wind up with an answer of, x squared plus 2xh plus h squared minus 3. And that's what f of x plus h equals all that, okay? As an ordered pair, it would just be a really messy ordered pair. This kind of stuff isn't written as ordered pairs too often. And then for the last one, we want to know what f of x plus f of h is. So I did that down here where there's a little bit more room. If I substitute in x, I get x squared minus 3. If I take f and substitute in h, I get h squared minus 3. Combine those together, I get x squared minus 3 plus h squared minus 3. These two things are like terms, x squared plus h squared minus 6. And what I want you to notice is that these two things are not the same. If I take and compare this answer to this answer, they are not the same. And so what that tells us is that the distributive property does not work for functions. F of x plus h, which we found up here, is not the same thing as f of x plus f of h. Okay, so you cannot use the distributive property on a function. You cannot say I'm going to take this f and distribute it to both of those terms. That doesn't work. Okay, that's it. If you have questions, you'll be able to ask them in class.